Hello everyone, I am Bhavani Chappadi. I am going to deliver a presentation on the IoT internship. Uh, internship. In this, in the internship, we have learned the concept based on embedded systems. In this, we have firstly learned the introduction to C and data types and conditional constructors and operators and arrays, pointers and functions, recursion, const with pointer and string, preprocessing storage classes, essential of C++, object, class, constructor, and destructor. And lastly we have learned the home automation project. In that, design elements and simulation and conclusion. Firstly, what is meant by embedded C? Embedded C is most popular programming language in software field for developing electronic gadgets. Each processor used in electronic system is associated with embedded software. Embedded C programming plays a key role in performing specific functions by the processor. In this, we firstly learn the numbering data introduction to C and data types. In that, firstly we learn the number system. A number is generally represented as in the form of decimal, octal, hexadecimal, and binary form. In this embedded C, the range of the decimal number is 0 to 255, and octal is 0 0 0 to 0377, and the range of the hexadecimal is 0 to 0xFF, and the range of the binary is 0B 00000000 to 0B 11111111. So, in this, how to convert a octal number to the binary number? Let us consider an example of 324. It is in the form of octal number. Firstly, we convert each digit into their equivalent binary number. Like 3 is converted to 3 is in the form of binary is 011, and 2 in the binary is 010, and 4 is in the form of 100 in the binary form. Then so 324 in the octal is 324 in binary is 0110 10100 is the binary form of 324, which is nothing but 1101010. In this, we have learned how to convert an octal number to the binary number. Then let us consider a 472, which is in decimal form number. It can be converted into hexadecimal by dividing the 472 by the 16. The remaining it can be converted as like this. Then the decimal 472 in hexadecimal format, we can get a value of 1D8 in the hexadecimal format. And next, 324, which is a octal number, it can be converted into the binary number, as we already see in the last slide. That is 324 is converted to the equivalent binary number, and we get we get the equivalent binary format. Like that only, the 1D8, which is a hexadecimal number, it can be converted to the octal. By converting each digit to the equivalent binary format and then concatenating all the binary forms and converting their equivalent octal numbers. That is conversion of binary formats of the hexadecimal number and converting their binary formats to the octal numbers by their equivalent in the equivalent decimal format. That is, we can get a hexadecimal of 1D8, which is a hexadecimal number, to its equivalent octal number 0730, which is nothing but 370 in octal number. Then let us consider an example of binary number format, that is 111 to its equivalent decimal format. In this, we get a decimal number of 472 by converting the binary numbers to the decimal number, which is a power of 2. So we get the decimal number of this number is 472 in the decimal format. Let's learn about the data types in the C languages. In C, we are having a data type. Mainly, we have two data types, that is integer and real. Integer data types consist of characters and integers, and real data type consists of float and double. In this, integer type is used to represent the whole number, including both positive and negative integers. The size of an int in bits and the range of values in this int type would have been 4 bytes in the 32 bits. And the size and the character char is used to represent the unsigned char data type is having a size of 1 byte, irrespective of the compiler. The signed type of character can hold negative values and as well as positive values, while most types are signed by default, like it consists of short, int, long characters. It is an unsigned by default. It represents the character data type and it can be either signed or unsigned. It's a constant size of 1 byte for both cases. Keyword char is used for declaring character type variables. Then real data type consists of float as well as double. The float data type is used to represent a real number with a fractional part. The size of a float in bits and the range of values it can represent can vary. Float for general measurable in seconds, distance, temperature. Like these values can hold the float size data type. And the double, if it holds the size of the double data type is 8 bytes. That is, its value will be range Its range is from 1.7e to 308 to 1.7e plus 308. Let us consider some examples on the data type. How can we print the data type? Let's consider a program that is hash include studio.h int main char option. We declare some uh, here we are declaring character data type, integer data type, and float data type. Then we are printing the character is the character and integer and the float value. So then the program is ending with returning a 0. Here we the after we after the execution of this program, we get the output as the character is option, the integer is age, the float is height. And let us consider a second example of printing size of character, size of integer, size of float. In this, size of is used to get the size of the characters in data type and integer data type and float data type. Here we are declaring the character data type character as an option, integer as age, and height float data type as a height. And printing the size of character is size of the character and size of the integer variable and size of float. Then at the end we get our output of sizes of the data type.
Hi, hello everyone. Good afternoon. My name is Rahul Allure. I am from Bhimanna Khandre Institute of Technology, Bhalki. Before starting the seminar, I would like to thank for Emertex Information Technology for providing this wonderful opportunity. So, I completed my internship on IoT from Emertex Technology and I'm going to do a presentation now on some operators and arrays. What is operator? Operators are nothing but a special symbols that instruct the compiler to perform a arithmetic operation or logical operation on operands. In operators in C, operators will perform two things. Well, that is, operators can be do perform an operation on operands, and the second one is it will returns a value. In operators, operators are classified into many types like a arithmetic operator, logical operator, relational operator, assignment operator, bitwise operator, so on. Now we will discuss one by one operators. First of all, first we take arithmetic operators. Arithmetic operators. Arithmetic operators are nothing but which will perform the operations on two operands. Arithmetic operators are classified into five types. That is multiplication, division, modulo, addition, and subtraction. This table shows the precedence and the associativity of the operator. The first precedence is given for the multiplication, second precedence is given to the division, and third modulo, fourth addition, and last one is subtraction. And the associativity of the multiplication, division, and modulo is given performed from left to right, and addition and subtraction right to left. Let us take an example of arithmetic operation. Here we took an let us take a variable num1 is equal to 0, num2 is equal to 0, and we perform a one second. Okay, no problem. And we are going to print a statement and perform an operation in the we are going to print a statement in a printf statement and we perform an operation. If sum is sum of two operators, sum of two number is sum of two number is nothing but percent d num1 plus plus and plus plus num2. Num1 plus plus is nothing but it is a post increment operator, and plus plus num2 is a pre increment operator. Plus plus post increment operator nothing but the post increment nothing but it will take the value first as num, and later it will be incremented by 1 as a post increment. And pre increment is nothing but it will increment the value by 1 before, and later it will update. Output of this program, let us see now. For example, let us do a let us bring an output. Num1 is what is the initialization of num1 is 0. 0 plus plus, it is 0 has been taken as first 0 as it is, plus num2 is 0. It will increment by 1 before, it is a pre increment, it will increment by 1. 0 plus 1, the output is 1. The sum is 1. Let us compile in a compiler. Here let us run this program. Just the same program is here. Let us run. Sum is 1. The output is sum is 1. This is an arithmetic operation. Instead of we can change also my subtraction operator, and let us run this program. Output is -1. In this way we perform an arithmetic operation. Now let us move to next operator, that is logical operator. Logical operators nothing but logical operators are nothing but when more than one conditions are having, we are going to check using these operators. Logical operators are classified into three types: logical NOT, logical AND, and logical OR. And associativity of the logical operator is also shown in the table here. Associativity of the logical NOT is right to left. Associativity of the logical AND is left to right. Associativity of the logical OR is left to right. Here are the special operator symbols. Now let us discuss one by one. Now now let us take a logical OR operator. Logical OR operator, I will do a truth table here. Logical OR operator, if the condition 1 is false, and also what is the logical OR operator? Any one operator, any one condition is true, it will resultant value will be true. If both the values are true, both the values are false, the resultant output is false. If first condition is false and second condition also false, the resultant output will be false. And also same here, when we giving a first condition is false and second condition is true, the resultant output will be true. In this way the logical operator will perform an operation. Now let us discuss about logical AND operator. If when logical OR operator will perform when both the conditions should be true, that time the resultant output will be true. Else any one of the operator is any one of the condition is false, the resultant will be false. That is a logical AND operator. Now let us discuss about logical NOT operator. Logical or NOT operator, when input is false, the output will become a true, and when input is true, the output will become false. This is a logical NOT operator. Okay. Let us take an example of logical operator. If let us take to num1 is equal to 1, num2 is equal to 0. Our condition is num1 plus plus num1 and logical OR num2 plus plus. We are incrementing before, that is pre-increment. Num1 is pre-incrementing and num2 is post-incrementing. Num1 is true. Any non-zero value will be considered as true, and zero value be considered as false. In this example, num plus plus, it will pre-increment num value is 1 and will pre-incremented, it will become 2. 2 this 2 is true. This logical this will enter into the body, and then later it will print num1 is percent, num1 is percent, and num2 is, let us run this program in compiler. Wait a minute, I will copy this program, control plus C. I would like to run this program in compiler, control plus V. 1 minute, I will write studio.h, and here this is an ASCII value, so I should have to convert into double four. And now let us run this program. Okay, so I was not using this. Now run this program. Num1 is 2, num2 is 0. This is an output of the logical OR operator. Now go for logical AND operator. This is the example of logical AND operator. Let us copy this program and run this program in the compiler. We'll copy this program. The output will be 1 minute, sorry, here it is some constant double quote. Now run this program. Num1 is 2, num2 is 0. This is a logical AND operator. In the same way, logical NOT operator will be same. Now let us discuss about relational. Next operator, relational operators. The relational operators are classified into 6 types: greater than operator, lesser than, greater than or equal to, lesser than or equal to, not equal to. Let us take an example of logical relational operator. Now if I will one data, I will convert this as double. Take a double. If num is equal to, if num1 is equal to 0.7, if a condition is, if num1 is equal to 0.7, it will, when the condition is true, that is num1 is equal to 0.7, it will enter inside the if condition, else it will, and else it will enter into the else statement. Let us check what will the output of this program. Control plus C. Let us run the program in compiler. I will run this program. The output, let us check what will be the outcome. What is missing here? Let us see. Printf first, it is equal to, what is going to missing? Run the program. Yes, it is equal. 0.7 is equal to 0.7. Yes, it is equal. If let us I will give 0.8, or else this one is program, or else it is not, it is going to print 0.8 is not equal to 0.7. It will not enter inside the if statement, it will enter into the else statement and print the no, it is not equal. Now go for next operators. A bitwise operator. Bitwise operator perform operation on bits. The operand type shall be integral or return type will be integral value. Bitwise operators are follows. Bitwise operators are bitwise AND, bitwise OR, bitwise XOR, complement operator, right shift bitwise, left shift. Let us discuss one by one. Bitwise AND. Bitwise AND of bitwise AND in adding of all the bits into two operands. Bitwise operators. Let us take an example. Here 0 0 let us consider, let us take on the value 0x61 and 0x13. We wrote this value in a binary hexadecimal value into binary form. It is 1101000010. In this way I will going to perform an AND operation. 1 1 plus 1 1, 0 plus 1 0, 0 plus 0 0. In this way the bitwise AND operation will be performed, same as that of OR operation and XOR operation. Complement operator, complementing all the bits of the operand, that is a complement operator. What is let us take an example. Let us take an example. What 2, let us take an example 2. A second, I will take here 2 2. What that 2 is decimal value is converted into binary. What is 2 0 1 0 0? What is that value is converted into complemented. Right shift, left shift. Right shift by shifting all the bits right and times by introducing zeros left, and left shift the bits are left and times introducing zeros right. This is a left shift. This is a example bitwise. Here is a operation. Value value, it's the syntax. Bit counts, so value, value and how many bits. Let us take an example. A is equal to 91. Say A is equal to 91 and A is shifted by 2 bits. Original value is this one, and this value is converted into binary and shifted 2 times to left. This binary value is shifted into 2 times into 2, and LSB is stored as 0. Same as the right shift also. Size next operator is size of operator. Size of operator will be nothing but it will calculate the size of the data, value and data type. This is called as size of operator. It will count the values, count the size, except in this way. For example, here is an include. Int main, int num is equal to 5, printf. Let us I took the variable as num and initialize with value 5, and we are going to print that size of the integer data type and size of the number data type, num value, and size of the initialization value. Here return 0. The output of this is size of the integer is 4, num value is 4, and size of the 5 is 4. Let us print this or print in a compiler. Now let us run this program. Output 4:4:4. Size of the integer is 4, size of the num value is 4, size of the 5 is 4. This is a size of operator. Let us now discuss about next the ternary operator. Ternary operators, nothing but it will, here is the syntax of the ternary operator. Condition, expression 1 and expression 2. In the ternary operator, instead of writing the multiple statement, we are going to use just one single statement. We can write a program to finding the for example, just write take an example of finding the largest of two numbers using a Turner operator. In num1 is equal to 10, num2 is equal to 20, and storing this value in num3. Now we are going to write a condition. Here is a condition: num1 is greater than num2. It is going to, if condition num1 is greater than num2, it is true, it will print num1. If num1 is less than num2, it will print as num2. Let us run this program in a compiler. One second. I will run this program. The output will be our greater number is 20. The number largest of two number is 20. Now let us discuss arrays. Array is nothing but is a collection of data of same data type. Collecting the data or storing the data in a same container or in a contiguous memory with the same data type. First element, for example, I will show you arrays. Syntax of the array: data type name, size, where size is the number of elements and size of the array would be size of data type. Example, int data type, age is the variable name, 5 is the size of the array, and we are storing the 5 values. The size in a normal program, we are storing, for example, wait a minute. The size of this array is 20 bits. It will take a size of the memory allocation will be 20 bit. Integer have data type is 4, and the total array has a 5 data. It is 5 into 4, 20. 20 is a it will take a 20 memory allocation. Index and the indexing starts from 0 and should end at size array size minus 1. For example, array 5 will be have to be indexed from 0 to 4. Here is this index is 0, index 1, index 2, index 3, index 4, and the base address of the index is should be first, and later base address of second index is adding plus 4, base index of third address is plus 8, index of 4 plus 12, and index of 5 plus 16. Here is an example of an array. Let us consider an example of an array. Instead of writing a multiple statements, you are writing in a contiguous memory. You are reducing the multiple statements into small memory. I want to print 10 to 50 at a time. Let us take here is an example. Let us write a program for index is equal to 0, index is less than 5, and here are total 5 data types. 5 size of the array is 5. It is taken here as 5, and we are incrementing incrementing by 1. Let us run this program in a compiler. Run this program. 20, 30, 40, 50 less than or equal to. Let's run this. The output will be 30, 40, 50 and 0. Oh, at the underflow, it will take as that one. Now go for next example. Arrays initialization. Array initialization is this as the array initialization and size of thank you.
Hello everyone, this is Nivedita from Bhimana Country Institute of Technology, Bhalki. Today I am going to share the project which we are done in our during internship program. In that internship program, we learned about home automation project. In that, before going in brief about home automation techniques, first you should know about the Internet of Things. What is IoT? IoT stands for Internet of Things. It refers to the interconnected of physical devices such as appliances and vehicles. Here, Internet nowadays, Internet of Things plays an important role in every application. And Internet of Things, it is the networking of physical objects that contains the electronics embedded with their architecture in order to communicate and sense interactions among us each other or with respect to the external environment. So IoT, which is helps us to communicate with each other. In upcoming years, IoT-based technology will offer advanced levels of services and practically change the way people live their daily lives. And what are the advancement in IoT are? First one is it takes the advancement in medicine, power, and agriculture, smart cities, and so on. And what are the main components of IoT? So let's go with the what are the main components which are used in IoT. First one is control units. Second one is cloud computing. Third one is availability of big data. And fourth one is networking connection. And fifth one is low power embedded systems. And sixth one is sensors. First one is control units. In Internet of Things, there are control units. It is a unit of small computer on a single integrated circuit. In single integrated circuit, there is a small unit that is called as control unit. That is microprocessor or processing core, memory and programmable input-output devices and peripheral. It is responsible for major processing work of IoT devices and all logical operations can be done on this control units. Next, go for the cloud computing. Cloud computing, nothing but it is a place where large data can be stored. Data collected through IoT devices is massive, and this data has to be stored on a reliable storage server. So that data can be stored on cloud. This is where cloud computing comes into the play. The data is processed and learned, giving more room for us to discover where things like electrical faults or errors are within the system. Also, it helps us to find out the where errors are present and what are the action will be taken for a particular error. And availability of the big data. We know that IoT relies heavily on sensors, especially in real time. As this electronic device is spread throughout every field, and the usage is going to trigger a massive flux of big data. So next one is networking connection. So networking connection, in order to communicate, internet connectivity is must where each physical object is represented by an IP address. So in order to exit the internet, we have to have IP address of that particular internet. Then only we can communicate with each other. However, there are only a limited number of addresses available according to the IP naming. Due to the growing number of devices, this naming system will not be feasible anymore. Therefore, researchers are looking for another alternative naming system to represent each physical object. Then go for the low power embedded systems. And the embedded system, as you know that embedded system is the combination of hardware and software to do a particular task. Here, in embedded system, low power embedded system, low power means it will not require any high power for doing any functions. So less battery consumption, high performance,
performance are the inverse factors that play a significant role during the design of electronic systems. Then go for the sensors. Sensors are the most major important parts in IoT applications. It is a physical device that measures and detects a certain physical quantity and converts it into signal, which can be provided as input to processing or control unit for analyzing purpose. And here, what the sensors means, which detects a certain physical quantity, and after that it will convert that signal. It will convert that into signal, which provides the input to the processing. So, what are the different types of the sensors? First one is the temperature sensors, image sensors, and obstacle sensors, gyro sensors, RF sensors, IR sensors, MQ02/05 gas sensor, ADR sensors, ultrasonic distance sensors. These are the sensors which are included in the Internet of Things. There are two ways of building IoT. First one is form a separate internet network including only physical objects. We have to form a separate internet network including only physical objects. Second one is make the internet ever more expansive, but this requires hardcore technology such as rigorous cloud computing and rapid big data storage. This is expensive. In the near future, IoT will become broader and more complex in terms of the scope. Nowadays, the scope of IoT is not down. It is keep going. It will change the world in terms of anytime, any place, anything in connectivity. Let's go with the how Internet of Things working. As you see here in this diagram, here is the environment where home, car, and a person is present, and here we are having the having our IoT. In IoT, we are having main important major parts like actuators, microcontrollers, and sensors, and things to do a particular task. And then interface, which was used to interface between the users and the internet. And by this IoT, we can access the information from this IoT, and then that can be used for web applications, communication interfaces, and data management and data repositories. This is all about the Internet of Things working. And how infrastructure of the IoT looks like. Here, as shown in figure, IoT, this is the architecture of the IoT where it consists of cloud infrastructure and things and gateways and network infrastructure, where gateways are used to pass the any information from one place to another place, so the gateways only. And network infrastructure, as you can see here, in this diagram, we are having IoT where actuators, microcontrollers, and sensors and things are present. Next, go with the characteristics of IoT. What are the characteristics of IoT? First one is massively scalable and efficient. This is efficient, and IoT-based addressing will no longer be suitable in upcoming future. And abundance of physical objects is present that do not use IT, so IoT is made possible. In internet, in some of the instances, they do not use IT, so IoT is made possible. Devices typically consume less power. When not in use, they should be automatically programmed to sleep. And a device that is connected to another device right now may not be connected in another instant of time. Intermittent connectivity, IoT devices aren't always connected. In order to save bandwidth and battery consumption, devices will be powered off periodically when not in use. Otherwise, connections might turn unavailable and thus prove to be inefficient. Then go with what are the applications of IoT. First one is healthcare applications. It is used in hospitalization and where healthcare applications, which is used in healthcare applications and automobile and logistic and transport and business and wearable health monitor and smart cars and smart buildings and some home automation. These are all the applications of the IoT. Then go with the embedded system. What is embedded system and structure? We are looking further slides. First one is what is embedded system. An embedded system is a combination of computer hardware and software to do a particular task. And embedded system is also a function which larger system. Here any software which are included in the hardware or big hardware, it can be function to do a particular task. So industrial machines, consumer electronics, agricultural and processing industry devices. These are all the applications of the embedded system. Then go for the structure of the embedded system. The structure of the embedded system consists of a processor and a power supply, and these are the application circuits and input devices and interfacing devices, driver circuits and output devices. And in power supply, we are giving a power supply to program memory and time, and it consists of time or the counter and parallel port and processor. And after that, we are having interrupt controller, data memory, and serial port. These are the main important parts of the embedded system. Let's go with the what are all the functions of each embedded system part. First one is the processor. The processor, as you know that the processor is the heart of the embedded system. Here, the selection of the processor is based on the instruction set, maximum bits of operation on the single architecture and logical operation, and the speed should be high while choosing the processor. And algorithm, processing and capability, and types of processor. These are all the processor which will do different functions. And then go for the power source. Power source is, as you can see here in this diagram, we are having a power supply. So let's go with the function of this. And internal power supply is must, as required from power up to power down to start time task. In order to do task, we have to give the power supply. Also, it can run continuously, that is same on systems. Consumes total power, hence efficient real-time programming by using the proper wait and stop instructions. And we have to use wait and stop instructions to start the work and to stop the work. And can enable or disable some units which are not in use. Can save or limit power consumption. And we are using the clock or oscillator circuit. The clock circuit is used for CPU and system timers and CPU machine cycles. Clock controls the time for executing an instructions. Clock oscillator may be internal or external. It should be highly stable. This is all about the clock oscillator circuit. Then real-time clock. It also has real-time clock. It requires to maintain scheduling various tasks. It maintains various tasks based on the scheduling, and for real-time programming, RTC also used for driving timers, counters used in the system. Reset circuit and power on reset. It also uses reset circuits and power on reset. The reset process starts executing various instructions from the starting address, and system program that executes from beginning, system booter program, and system initialization program. And in order to initialize the program, we have to have reset circuit and power on reset. And let's go with the memory. And the embedded system, which includes the memory, internal flash or RAM, PROM, programmable read-only memory, or in external flash or RAM or PROM for the microcontroller. These are the some functionality of the components of the embedded system. Then go with the microcontroller. A microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. And in an embedded system, microcontroller plays an important role to handle a particular task. This typical microcontroller includes the processor, memory, and input peripherals on a single chip. Then go for the components of the microcontroller. Microcontroller includes timer, counters, and pulse width modulation pins, and ABC block and DAC block, processor, memory, and input-output ports, and microprocessor versus microcontroller, RAM, ROM, and its types. Next, go with the project. Our project is home automation. In this project, it is a IoT-based home automation solution using Arduino Uno board. In this project, we are used Arduino Uno board. To remotely control the device, we use the app named as Blink IoT. So, by using the mobile, we have the app that is called as Blink IoT app, which is installed in our mobile. So by using the mobile only, we can control our devices which are in home. You can see, you can further see in the next slide. We automated the garden lights where they brighten according to the sunlight. So according to the sunlight, we are turning on the lights and turning off the lights. Whenever there is a light, sunlight is available, then there is turn off light. When the sunlight is not available, then there is automatic turn on the light. Temperature control system is automated. So by using in this project, we can control the temperature of the system by using the mobile blink IoT. And last and not least, the water tank is automated by controlling the inlet and outlet valves respectively. And whether the water tank is full or empty, this can be controlled by using the Blink IoT app only. So this is all can be done in this project. That is called as home automation technique. Then go for the project objectives. What are the objectives of this project? Connect all the home appliances to Arduino and integrate with its Blink IoT app and cloud. Obtain critical notifications regarding temperature and Blink IoT app. Check the real-time status of the temperature and water level on the Blink IoT app to control the garden lights automatically. One by one, you can see in next slide. Then go with the need for home automation. Why we need home automation? Because nowadays all of you going smart home, right? So we can control. We have new technologies, and we want always new technique to start up. And so home automation is the one technique which is very useful for all of us. Home automation devices are controlled by your smartphone. Home automation, as you can see here, this is a home. This home, by using this mobile app, by using the Blink IoT app, which is there in the mobile, you can control all the functionality of the devices wherever you might be. And which means we can adjust the system from anywhere. So we can adjust the system from anywhere in your mobile, whether you are hours from home or just want to stay put on the couch. There are also some surprisingly these products are more convenient engine in place. Here, a smart home automation system. As you can see here in this picture, this is a smart home automation system structure. Why smart home automation system is needed? Why this is needed? Because every person has a dream house, right? So how would you be described your ideal dream house? So in order to achieve our ideal dream house, we have to go with a home automation. It varies from person to person. Some would like to a glass house, whereas others would prefer a small house built in a hilly place. But most people will agree on a dream house with the most adorable lighting which changes with the occasion. The dream house should play music depending on your mood and activity. Depending on your mood, the dream house can also do different activities. Your dream house temperature should be kept at the most optimal level by itself and filled with sweetest aroma. The dream house should be keep a track record of people entering and leaving. And it also takes a track of the people who are coming inside the home, who is going outside the home. These are all controlled by home automation technique. Well, let me tell you, with the latest smart home automation system, you can crystallize your dream house into reality. So you can crystallize your dream into reality also. The concept of smart home automation system has been evolved. The smart home concept was born in the invention of remote controls by Nikola Tesla back in 1898. Since then, there was always been a constant improvement in the smart home automation system. The smart home automation system is the need of time and the requirement of every individual. It can ensure your convenience and comfort without compromising your privacy. So you can handle all your gadgets, buttons such as audio speakers, and like TV, thermostats, and security cameras and locks system. With the help of a smartphone or through the internet. With the help of internet, we can control our TVs, lights, securities, camera, etc. The smart home automation system offers the most intelligent way of controlling your home. You need a smart home automation. Why? Then go with the why home automation is needed. Because it's needed because of remote control and intelligent security. From this we can say that the home automation is needed just because of remote control and intelligent security. In order to maintain a security, we have to go with automation. Remote control, how we can control remotely. With this latest smartphone automation system, you don't need to be worried about the turn on TV at home when you are away from the home and nobody is in the house to turn it off. Smartphone automation system offers you the opportunity to control your devices through a remote controlling system. So this is how you can controlling any devices remotely. You can manage the devices from thousands of miles with the aid of smartphone and the internet. Then go with the intelligent security. The following reasons is need for intelligent security. The home automation solutions can help in managing the security of your home. So it plays an important role to provide a security to our home. You can collect data through gadgets like cameras and sensors. Here, as we know that this standard system home automation techniques, it includes sensors also. So by using sensors and cameras, we can capture our recordings and all data and analyze those data with the help you enhance your home security. By using these are all the components we can provide the security to our home. What are the advantages of home automation? First one is energy efficiency and comfort and convenience, which is convenience to use, and remotely you can control, enhance security, it provides security, better control over the devices, which has the control over the various devices which are included in the home automation technique, and peace of mind, it provides a peace of mind because the stress can be reviewed by using home automation technique, and the higher value of your house and better impression. These are all the advantages of the home automation. Let's go with the scene control. When it comes to customizing the house and lighting a particular area of special occasions, scene control is essential. In order to, whenever you want to control the lighting of a particular area, scene control is come into existence. The lights can be changed to match your mood and provide you with the peace of mind. User interface. The smartphone home automation system is designed to meet the homeowner's particular requirement and enhance convenience and comfort. With the help of a simple mobile application, you can control your house overall atmosphere and look. Then go with the what is Arduino Uno board. Here, as you can see here, this is the Arduino Uno board, then go with the structure of the Arduino board. Looks like how it looks like. This Arduino Uno consists of Arduino Uno standard board of Arduino. Here the Uno means one in Italian. It was named as Uno to label the first release of Arduino software. It was the first USB board released by Arduino. It is considered as a powerful board used in various projects. And it is simple Arduino board where we can use many of the projects where this Arduino Uno board can be used. And Uno means it is one in Italian. Arduino Uno includes this Arduino Uno having analog pins and GPIO pins and LED and switch. And as you can see here, Replica 38 is the microcontroller, and we are having analog pins and digital pins and PWM pins, and the PWM pins can be represented on the board by using the star symbol followed by a numeric value, and the Arduino Uno inputs 6 analog inputs, 14 digital inputs. It has totally 6 analog inputs. It has totally of 6 analog inputs. As you can see here, from A0 to A5, these are the analog pins, and it has totally of about 14 digital pins. 14 digital pins from 0 to 13. From 0 to 13. These are called as the digital pins. These are called as the analog pins. And we are having power supply here, which is connected to ground and 5 volt ECC, and some other parts also included in this board. And USB connector, power jack, and an inside to serial programming header. It is programmed based on the IDE. What is the IDE which is used for programming? It is Arduino, which stands for Integrated Development Environment. It can run on both online and offline platforms. So whenever you are writing the programs on IDE called Arduino, so it can be operate in both online and offline platforms. The IDE is common to all available boards of Arduino. Next, go with the what are the components of Arduino board. As I told you, from 0 to 5, 6 analog pins. So here you can see these are the analog pins. And this is indicate input, and this is the ground pin, it is a VCC, and it is a 3.3 volt voltage pin, and it is a reset pin. And here the microcontroller used here is Atmega 328 microcontroller. And here we are having a inbuilt LED, power LED, and reset button is, as you can see here, and these are the digital input output pins, and USB and crystal oscillator, here you can see, and voltage regulator and power button, and transmit and receive LEDs, and AREF. These are the components of the Arduino Uno board. Then go with the one by one explanation of the parts of the Arduino Uno board. First one is Atmega 328 microcontroller. What is Atmega 328 microcontroller? It is a single chip microcontroller of the Atmel family. It is belonging to the family called Atmel. The processor code inside it is of 8 bits. The processor is of how many bits? It is of 8 bits. It combines memory like SRAM, static random access memory, EEPROM, and flash. Analog to digital converter also it has. And SPI, serial to parallel serial port interface. Serial ports, it includes serial ports and input output lines, and registers, timers, and external and internal interrupts and oscillators. These are all come under the Atmega 328 microcontroller. Then go for the ICS pin. ICS pin is called as in-circuit serial programming pin, which allows the user to program using the firmware of the Arduino board. Firmware, what is firmware? Firmware, it is a software. So, at the starting of your firmware, which acts like operating system. So, in order to have communicate with the hardware with the software, we have to have firmware in between them. So then only we can execute or we can run the programs on the Arduino. Power LED indicator. LED is a light emitting diode. It has on status and off status. The LED shows during the on status, the LED shows the power is active. When the power is applied, then the LED, you can say LED is on. When the power is off, you can say the LEDs will not be lighted, that is power off. And digital input output devices. Here, the digital pins have the value high and low. The pins numbered from D0 to D13 are digital pins. And digital pins are nothing but it is in the form of binary, right? Binary in terms of 0 and 1. 0 indicates low and 1 indicates high. So, next go for the transition and restriction LEDs. The successful flow of data is represented by lightning of these LEDs. The successful flow, whether the data is flowing or not, when that can be proved or that can be taken by using TX and RF LED. Then AREF, which is the analog reference. Pin it is used to feed the reference voltage to the Arduino Uno board from the external power supply. Then go with the reset button. It is used to add a reset button to the connection. In order to reset, we have reset button on the board, and USB allows the board to connect the computer, and in order to connect the computer, USB which is used in order to connect your computer to Arduino board, we are using the USB. It is essential for the programming of Arduino Uno board. While we are after compiling your program on the Arduino software IDE, then you have to connect that program into your computer. That can be done with using USB cable. Then crystal oscillator. The crystal oscillator has a frequency of 16 MHz, which makes the Arduino Uno a powerful board. Crystal oscillator it will make the power powerful board to the Arduino. And voltage regulator. The voltage regulator which converts the voltage, input voltage to 5 volts. Ground pins which has the voltage of 0 volt, right? The ground pin acts as a pin with 0 volt. Vin is the input voltage. And analog pins which are from A0 to A5. In order to read the analog values, we have to use analog pins. For example, in sensors can read only analog values. So we have to connect the sensors externally by using the analog pins only. That is from A0 to A5. It can act as a GPIO, general purpose input output pins. Next, what is PiximLab and Blink IoT app? PiximLab, which is used to simulate the code and access various peripherals. In order to connect peripherals to your Arduino Uno board, we have PiximLab, and in order to control your devices remotely, we have Blink IoT app. You can create a smartphone applications that allow you to easily interact with microcontrollers or even full computers such as Raspberry Pi. Virtual COM port. It is virtual COM port. Virtual is the online port. It is an online port. It is used to connect our PiximLab virtual Arduino to serial terminal of Arduino IDE. Blink IoT app provides a cloud feature to us so that we can receive the data from sensors and store it in our app. By using the Blink IoT app only, we can turn on and turn off our button, so we can control our devices remotely. This is all about PiximLab and Blink IoT app. As you can see in this diagram, here we are having Blink app in our mobile, and here we are having an internet interface, and here we are having our PiximLab, nothing but Arduino Uno board, and by various devices which are connected to this Arduino Uno board. These are all devices which can be controlled by this Blink IoT app. Whenever you bring this Blink IoT app having the switch here, we can by turning on and turning off this switch in the mobile app, we can control turning on and off of the fan and the bulb, pump and CFL. So this is the functionality of the Blink app. Then go with the light dependent resistance. Here, what is the use of light dependent resistance? In this home automation technique, we are used light dependent resistor. Here, light dependent resistor, as the name itself indicates, that it is a type of the resistor. It is a variable resistor. It is works on the photoconductivity principle. That means that it will changes the resistance according to the intensity of the light. When the sunlight is incident on this LDR, then the resistance will be more or less. The resistance will be less because the sunlight, when applied on this LDR, it allows the more electrons to flow inside the LDR. So the current flowing inside the LDR increases. So then so resistance is decreases. There is a current, and there is a in order to control the guard light, we are using the light dependent resistor. Then at that time the LED is off and the light is off. Its resistance decreases with the increase in the intensity of the light. It is often used as a light sensor, light meter, automatic speed light, and in areas where we need to have light sensitivity, it is also called as light sensor. Here the LDR is usually available in the size of 5 mm, 8 mm, 12 mm and also 25 mm dimensions. The LED lights are connected to LDR via ADC, analog to digital converter. Here the LED lights are connected to LDR. LED lights can be controlled by this LDR because depending upon the lights which are incident on the LDR. The ADC converts ADC which is present on the board, Arduino Uno board, because we have to convert ADC analog to digital. Because Arduino Uno board which is we have to convert into digital. Convert analog input by the LDR into equivalent digital form, which is converted later by certain formula to 0 to 255 as a upper bound. Again, it has to convert into a unlock digital to analog by using some certain formula. So next one, let we blow the LED. Then go for the garden light control. Here, as you can see in the diagram, here we are having the Arduino Uno board and LDR sensor and lights. Here what we are doing here is first LDR sensor. LDR sensors. When the light LDR sensors, when the light incident of these LDR sensors, and then it is connected to the Arduino Uno board can be connected with the lights. When the sunlight is off, then this light is on. When the sunlight is on, that is when the light is incident, then these lights can be off. The properties of the LDR sensors are applied to accomplish the controlling of garden lights. During the day, the outdoor light is maximum. So the LDR sensor detects the light and the garden light is turned off. So LDR sensor during the daytime, it detects the maximum light. So the garden light turn off. There is no need of light, right? So it turn off. Then whereas in the night, the outdoor light is very low. So the LDR sensor detects the light and the light is turned off. And the light is turned off. During the dark, the light is turned on. During the light, the light is turned off. This is the functionality of the garden light, how we are controlling the garden light. Next, temperature sensor. Temperature sensor which will sense the room temperature. Here as you can see here, temperature sensor LM35. In this project we are used LM35 temperature sensor. The temperature is recorded using the LM35 sensor which reads the analog values. The value is converted into binary value and the latter actual temperature is calculated by using the option value of voltage. The sensor does not require any external calibration to provide accuracy in results. The temperature control system consists of heating resistor and an LM35 temperature sensors and cooler. The temperature system which includes the resistor, LM35 temperature sensors and cooler. Analog value of temperature is obtained from the temperature sensor LM35 and display it on the CLCD. CLCD liquid crystal display which is used to display the values string on the CLCD after converting it into digital values using ADC. Control the temperature of the system by turning on and off of the heater and cooler through the blink IoT app. So by using the blink IoT app, we can turning on and off the heater and cooler. The feature of this system is that the temperature reaches 35 degrees Celsius. Heater turns off automatically to avoid the more heating. For example, if the temperature is increased beyond the 35 degrees Celsius, it turns off automatically to avoid the more heating. This is done by remotely by using you can control by using the mobile app, Blink IoT app. The notifications of the same is displayed in the terminal of the Blink IoT app. The notifications also declared on your mobile. As you can see here, this is the fan supply, this is the heater supply, and the Arduino Uno board, and we can control fan supply and the heater supply and how much heat is present and whether the fan is on and off. This can be controlled by using the Blink IoT app. Then here, as you can see here in this picture, here we are having the Blink IoT app and this is the Arduino Uno, and here we are having the CLCD and temperature system. Here, first Arduino here to Arduino Uno, we are connecting the peripherals like CLCD and temperature system, and notifications can be sent from Arduino to the CLCD liquid crystal display and temperature. The temperature system, first of all, the temperature system, what will do is the temperature system will send the temperature to the Arduino board. Along with that, the Arduino board sends the notifications to the Blink IoT app. So after that it will send the notification if the heater is more, it will send the command or notification to the Arduino Uno board, heater control, and then from Arduino board the heat can be controlled automatically in the temperature system. This is all about how we can control the temperature. And water inlet and outlet valve control. Here it includes read the volume of the in order to read the volume of the water in the tank. If the water nothing but control the volume of the water in the tank by controlling the inlet and outlet valve. It includes inlet and outlet valve by sending the commands for serial communication. So in order to control the serial tank, we have serial communication. In order to communicate, we are having the serial communication ports. So, display the volume of the water of the tank in the CLCD and also Blink IoT app. So, how much volume of the water is present inside the tank? That can be displayed on the CLCD on Blink IoT app. Here, the main feature is that as soon as the tank is full, the inlet valve is turned off. Nothing but when the tank is full, the inlet valve automatically turns off. And when the water level is in the tank is below 2020 layers, the inlet valve is turned on automatically in order to fill the water in the tank. And the notifications of the same is provided on the terminal of the Blink app. Whether the notifications can be provided at the terminal of the Blink, but the volume of the water, how much water is present inside the tank, that can be provided in the terminal of the Blink IoT app. Here, as you can see here, this is a Blink IoT app. We are doing ordering, and we are having the water tank and CLCD in order to display the volume of the water, how much volume of water present inside this tank, and here we are sending the volume, how much volume is present inside this tank to the Arduino, and then it will take a Blink IoT app and notifications can be displayed on the Blink IoT app. Then it will send the output valve control, input valve control, which valve we have to control, that can be controlled by passing through this Arduino, and the volume of the water and inlet valve control. The particular inlet or outlet valve can be controlled in the water tank. So this is all about water inlet and outlet control. What is the confusion? Using Blink IoT applications and Pixel Lab simulators, we simulated home automation where a temperature system serial can resemble light, heater, cooler, and water tank in the real time. CLCD acts like a dashboard used for displaying the events. Widgets from Blink IoT app, like buttons widgets, are used to control CLCD acts like a dashboard used for displaying the events. Widgets from the Blink IoT app, like buttons, and are used to control the heater, cooler, and inlet valve and outlet valve. Hence, the project to provide perfect solutions for home automation. So, this project provides the perfect solution for the home automation. Let's go with the water one by one. The simulation of LED, CLCD, how you can work on this. This is the code for to blink the LED. So in order to blink, to turn on and turn off, we are using this program. Here we are having the in LED light emitting diode. When we pass the current, so it starts eliminating the current. Here light emitting diode, which includes diode, which is supplied with the voltage, and here based upon the voltage we are supplied. It will turn on and turn off the LED. Here in LED we are done with two connections. One is called as sourcing circuit and sinking circuit. Then the LED which is connected to positive terminal of the Arduino, positive terminal with the Arduino with the 1, then it is called as sourcing circuit, and when it is connected to the 0, then it is called as sinking circuit. Let's go with the simulation. Then now export compiled binary of this program. So it's showing done compiling. Then go for the fixing lab in order to see our simulations, right? Then go for the fixing lab, and then go to file and load hex file, which you had compiled, and next go for the choose LED program to build, and Arduino, and load hex file. Here we done with the compilation. Then go for the modules and space parts. These are the previous programs. Remove this one. And go to outputs and select LEDs and click on the screen. So LED will come on the screen. So in order to operate it well, what we have to do is select in which pin we are turning on and turning off the LED. In the program, you can see here at the pin number 2, we are changing the brightness of the LED. We are turning on and turning off the LED. Here we are having white setup and white loop. And white loop, this instruction is used to execute the instructions repeatedly. So we are turning on, turning off the LED repeatedly, right? So this can be put it in a loop. This can be put it in a loop. So we are providing the delay because in order to for the visibility of the light, whether it is turning on or turning off or not, or else. That's why we are using loop. Inside we are having digital write. This is the function which is used for to turn on the LED, and digital write LED comma low, which is turn off the LED. So put your main code here to run repeatedly. So this is all about the programming. So what I am doing here is I will connect this LED to pin number 3. So go to properties and then go with the pin analog pin number 2. You can see here in this pin number 2. Okay. So then you can see here the turning on and turning off LED continuously. This is all of about the program called light emitting diode LED program. Next to go with the PLCD program. So this is the program of CLCD. Here in CLCD we are using I2C protocol and some libraries called as wire library. So in order to display the strings on the CLCD, we are using wire.h and liquid crystal I2C.h. And these are the some addresses. So here in CLCD, different types of CLCDs are available in the market. Here, in this project, in CLCD, I used 16 columns and 2 rows of CLCD. So this indicates the address, and this is the number of columns and number of rows. Here, initialize the liquid crystal library. In order to initialize this liquid crystal library, we have to install it first. And then first parameter is the I2C address. This is called as the I2C address. The second parameter is how many rows are in how many columns are in your screen. This is the number of columns and this is the number of rows. And then go for the, first you have to initialize the LCD. And what you have to do in this program is, first you have to initialize the liquid crystal display. And turn on the backlight. You have to turn on the backlight and clear the CLCD and cursor to the home. And then return to the home. Set the cursor, return to the home. Then to display the string. In order to display the string home automation, we have to set the cursor at 0 column and 0 row. So it have to print home automation. And in order to print the Emertex string, set the cursor at the column 3 and row 1. So, we are not executing this program repeatedly. We are not including data which can be executed repeatedly. So, I am not taking any data in this loop. So, let's compile this program. Go to Sketch and export compiled binary. So, done compiling. After that, go to Pixel Lab. So delete it. And then go with, you have to load that file, load hex file. Load hex file and go with the downloads where you have to put our program. And go to CLCD. The hex file is loaded. Then we have to go with I2C protocol, right? So we are using I2C protocol in this program. So LCD HT44780 I2C, you have to select this one and click on the screen. It is visible. So in order to do this, just right click on this PCB8574, go to properties, and here we have to select the pin 85 and analog pin 5. Here we have to select the analog pin 4 and then click on OK. Once again, you have to reload once again, and then go with the You can see here. The home automation Emertex displayed on the CLCD. Here home automation it is of how many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is all of about 16 columns. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. Nothing but 16 columns. And here Emertex is displayed in the second line. So this is all about how we display the index string on the CLCD. Further go with next program. File, open. As you can see here, this is the program about temperature sensor. It will sense the current temperature, ordinal temperature, I think current temperature is the current temperature of the room temperature. First of all, what we are having is in order to display the temperature on the CLCD, we are having CLCD program here. LCD backlight, LCD.clear, LCD.home, LCD.set cursor, and LCD.print. This is all about CLCD program. So we are visibly nothing, but we are seeing the temperature of current temperature. So to read the values from 0 to 1023, analog read values. So save it and compile it. Export by compile binary. Compilation is done. Go to Pixel Lab and file load hex file. Go with others and temperature system and click on this. This is the temperature system as you can see on the screen, and then go to properties, set the pin number 0. We can see in the output, so select not and then okay, no, wait for a while. What we are doing here is we are not seeing any heat. We are measuring the temperature, so go to temperature and select A0. A0 pin, then okay. So as you can see here, 27.34 is our temperature, current temperature.